Solve the radical equation. Square root of x plus 7 equals x plus 5. Anytime I'm solving a radical equation, I want to try to get so I have nothing but the radical on one side of the equal sign, which is what I have here. So now that I have that, I want to cancel out the radical by raising the entire side of the equal sign to whatever the index is of this radical. If I don't see an index written, I know that means it's a power of 2. So I want to raise both sides of my equal sign to the power of 2. So I'm squaring my left side, I'm going to square my right side. When I square my left side, the square and the square root are going to cancel out, so I'm going to be left with just what I have inside my radical. On the right side here, I'm squaring my binomial, so that's going to leave me with x plus 5 times x plus 5. I need to make sure I remember when I do this, it means times that binomial by itself. So when I go through and do this, I have to distribute my x to both the x plus 5 and the plus 5. I have to distribute my plus 5 to both the x and the 5. That's going to leave me with now a trinomial. So I have x plus 7 on the left, and on the right side of my equal sign, it's x squared plus 10x plus 25. To continue to solve this, I want to try to make it so I have 0 on one side of my equal sign. So I'm going to move my x and my 7 over to my right-hand side. And I'm going to do that by subtracting. I subtracted x on both sides, so that meant that 10x minus 1x is 9x. Subtracting my 7 with my other constant over here, 25 minus 7 is 18. So now I'm left with my trinomial, x squared plus 9x plus 18, and that equals 0. Now that it equals 0, I can go ahead and factor this right-hand side. I'm looking for two numbers that multiply to give me 18, but that add to give me 9. That's going to give me 3 and 6. So I can factor this to the binomial x plus 3 times x plus 6. This still equals 0. Because I now have two things being multiplied together that equals 0, I can use my zero product property that tells me that either of these two things being multiplied together is equal to 0. So that means my x plus 3 could be equal to 0, or that means my x plus 6 could be equal to 0. Finishing off by getting x by itself, I have to undo my plus 3 by subtracting 3 on both sides. I have to undo my plus 6 by minusing 6 on both sides. So I have my work there. I have now the solutions x is negative 3 or x is negative 6. Anytime I am solving a radical equation, I do have to check my answers to see if they actually work. Sometimes they won't. So I'm going to go back to my original problem and I'm going to check. I'm going to check the negative 3 first, so that means I'm going to substitute negative 3 in anywhere I see an x. Doing that, I have the square root of negative 3 plus 7 equals negative 3 plus 5. I want to get the same thing on both sides of the equal sign. So simplifying, negative 3 plus 7 is going to leave me with 4. On the right-hand side, negative 3 plus 5 is 2. When I square root both sides, I get that 2 equals 2. That checks. That is correct, so this is going to be one of my solutions. I need to check my other solution though, so I'm going to now take my original equation up here and I'm going to substitute negative 6 in to my problem. So that leaves me with square root of negative 6 plus 7 equals negative 6 plus 5. Simplifying, negative 6 plus 7 is going to give me 1. Negative 6 plus 5 is going to give me negative 1. When I take the square root of 1, I'm left with 1. 1 does not equal negative 1, so therefore that tells me that negative 6 is not a solution. So my final answer, my solution for this problem is going to be x equals what my x value was of negative 3.